So, Libgdx has a life cycle. Now, like most games, or game engines, it follows a loop where things happen X amount of times per second, and that's called a frames per second or FPS. So, like, how often does the screen refresh? We're going to look at 4 different things. We're going to look at the game class, screen class, the create methods, and the render methods. So first, let's start with the game class. And the game encompasses sort of what it describes. It describes what the data of the game is. Not exactly what you can see, but sort of what has happened in the game. And to be able to run, the game has a render method. So render is what gets run every time that the screen needs to get refreshed. So if we are doing 60 frames per second, render is going to be called, or render is going to run 60 times per second. So what's going to happen is that render is going to be called time and time again, and it's going to wait in between each time that it's called. And who's calling this? Well, it's Libgdx. So the game engine makes sure that render, whatever code is inside of that method, runs X amount of times per second. So run, wait for X amount of time, run again, wait for X amount of time, run again, and so on. Before we get to the render part, we have a create method. This create method only runs one time, and this is the first thing that runs when the game comes online. So whenever you click to start the game, create is going to have some code under it. You do some stuff, you set up your game, and then render gets called very quickly. So as soon as you create it, create's done, then you go on to render. Now what do you do in create? Well, you generally want to do 3 things, and these are the first things that we're going to begin with. In create, we are going to make different ways to be able to track the current state. So how many points do we have? How many enemies have we killed? Have we finished the current level that we're at? All of those things are part of the state. So we'll want to keep track of what's happening in the game. We don't create all of the levels all at once. We create the first level, so we create the initial screen, and then we set the initial screen to be the current screen. So we say, this is going to be the first level, set it as the current level, and whatever is currently the screen is what's going to be shown to the user and what's going to be drawn on the screen. So after create does everything that it needs to do and sets things up, render is going to start running. And what are we going to put inside of render? We're going to put 3 things, at least to begin with. We're going to put code to check what the current state of the game is. So maybe we have a variable that says true or false, the level 1 has finished. So then we go ahead and check that variable. If level 1's finished, then set screen to level 2. Once we set the screen, if the state has changed, we can also check if we are in a different state. Maybe the user pressed the X key or the P key, and each one of those keys is supposed to show a menu. So whenever we click on the X key, we're going to change some variable, some state inside of the game class, and then we're going to check that in render, and if that's been changed, then we want to show a menu. Now, the game sort of controls what's happening overall. Now we're going to go to the screen class. Screen class is a bit different from the game. So the game sets the current screen, but then the screen itself has to draw things. The screen works very similar to game. Screen has 2 methods. One is the constructor, which is called screen as well. In here we want to create a map, we want to load the map graphics. We want to create a player, we want to set the position of the player and the graphics for that player, whatever your sprite might be. And then we want to create a camera and a viewport and set the position of that camera so that we're able to follow perhaps the player or have a particular camera where we want to see things. After screen runs, which is the equivalent of create in the game, render is going to start running every so often. the same amount of times as games render, but it's a different render. What do we want to do in this render? Well, we want to draw things on the screen. We want to update the map if necessary, if something happened. We want to draw and update the player position. So if you press the key, maybe the player needs to move. So here we update it. And then we update the camera position. So if the player moved and we're following the player with our camera, then we want to make sure that we move the camera to where the player is. So what's going to happen? Sort of what is it that you follow? Well, you follow two things at the same time, in a sense. Render in game is waiting to see if the screen needs to change, and render in screen is waiting to see what should be drawn on the particular screen to show to the user. And both of them are handling some sort of state. Let's say that our player has hit a block, and that block releases an item. So as soon as we click a button, our player moves, that player touches a block, that block then changes, say, some state somewhere, saying in the next time that we render, you should draw an item on the screen. Great. So all of that would be done in screen. And screen is every time that render gets called, needs to check what is it that we need to draw on the screen now. Maybe something happened where a new thing needs to show up, or maybe the player died and we need to remove the player. Let's say that the player went all the way to the end, beat the final boss, so then we would tell game, change the state of the current game to show level 2. So then game is going to look at its render, and next time that render goes around, it's going to say, should I show level 2? It said, yes, you should. And then a whole new screen would get created. You would tell that screen what to draw, and then that loop will continue going. So you have two loops going on at the same time. And this is mainly what makes most games for the most part, but what you will follow in this class moving forward.